stop deploying LLM changes to everyone at once. This is the setup you'll be able to run after this, which decides a safe Canary for prompts and model routes, and serves with shadow evaluation. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Feature flags solve a practical deployment problem. You want to try a new prompt or a model route. You do not want to blast it to every user and discover a problem at scale. Success means exposing a small, measurable slice of traffic, observing behavior, and either expanding or rolling back safely. Think of a feature flag like a safe gate. It can admit a fixed percentage of users. It can include an allow list for VIP testers. It can flip off instantly for emergencies. For LLMs, we add shadow evaluation, where experimental responses are generated and measured, but not served. That gives a safety net and signals whether to ramp. At a high level, we will build a tiny system that buckets users, applies rollout percentages, honors allow lists and kill switches, compares two prompt routes using a cheap proxy, automatically ramps when the shadow route looks healthy, and guards risky queries. The code is a toy, but it maps clearly to a production Canary for prompts. Now let us jump into the first piece. Now, we will bucket users into stable cohorts. This snippet deterministically buckets users to roll out a new prompt by percentage. The list users provides readable identifiers that are easy to follow. The function bucket converts each user ID into a stable number from 0 to 99 using a byte sum modulo, which guarantees consistent assignment across runs. The variable rollout sets the percentage threshold for who receives the change. The list assigned collects users whose bucket score is under the threshold, and rate computes the exact rollout percentage actually achieved on this cohort. Increasing rollout moves more users into the change. Decreasing it reduces exposure. The printed counts confirm precisely how much traffic is receiving the variant. Next, we combine rollout with allow lists and a kill switch. This example introduces a feature flag evaluator combining rollout, allow list, and a kill switch. The dictionary flags defines the new prompt flag with a 25% rollout, a forced on allow list containing Z0, and a kill toggle for emergencies. The function flag on reads that configuration, short circuits off when kill is set, and otherwise returns true if the user is allow listed or falls under the rollout threshold. The list active represents who would see the new prompt right now, while overrides n counts those admitted specifically by the allow list. Increasing the rollout grows active, whereas setting kill to true instantly zeroes it. The printed values quantify both total exposure and explicit overrides. Now we evaluate prompt variants with a cheap proxy instead of live calls. This code compares prompt routes for flagged users using a simple length-based proxy. The strings base P and new P stand in for two prompt styles, one verbose and one concise. The helper simulate LLM produces a deterministic mock response by combining the prompt and the query, letting us measure response length without external calls. The list active holds the users currently routed to the new prompt. For a fixed query, new len and base len compute proxy sizes, and wins assigns every active user a win when the concise route is shorter. The variable rate converts that into a percent. The printed win rate summarizes whether the new prompt outperforms on brevity for exposed traffic. Next, we add automatic ramp logic that reacts to the shadow signal. This snippet ramps traffic automatically when the shadow evaluation looks healthy. The variable next rollout increases the percentage if the observed rate is at least 60, or decreases it otherwise, and clamps the result to valid bounds. The set prev captures who was eligible before the change, and cur recalculates eligibility after applying the ramped rollout. The difference cur minus prev yields a precise count of newly exposed users, stored as newly active n. Increasing the ramp step accelerates exposure but raises risk. Decreasing it slows change and reduces blast radius. The printed numbers show how many more users will see the new prompt and the new rollout level. Now we add a safety guard for risky queries and measure cost impact. This example adds a guardrail that reroutes risky queries while measuring cost. The set banned lists phrases that should not go through the experimental path. The function guard checks a query for those phrases, and route uses that check with the feature flag to choose the safe or new prompt. The list RS holds simulated responses for each user on one risky query. The value rerouted n counts how many flagged users were intercepted by the guardrail and forced to the safer route. The metric AVG cost computes a tiny per response cost proxy based on length. The printed values reveal how protective routing impacts safety and spend together. This toy sequence maps directly to production design. Bucket votes become consistent client identifiers. The flag evaluator becomes a centralized service or a lightweight local library. The shadow evaluation and ramp rules become a monitoring rule set that gates a traffic manager. Recap. Feature flags for LLM systems let you control who sees a prompt or model route and gather safe signals. Use them when you want gradual exposure, allow quick rollbacks, and collect shadow metrics. Caveat. Your proxies must be reasonably predictive. A wrong proxy can lead to unsafe ramps. Next step. Tune the ramp step and the success threshold. Try a slower step or a higher 60% success bar and measure how quickly exposure changes and how often you hit rollbacks. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.